Okay, so let's just go through this. First question, what's the purpose of the following methods? Start update and fixed update. So start gets called once when that script first launches. To be the most accurate, probably on a, it gets called once per game object the script is attached to. That's the most accurate version of it, but it only gets called one time. Update gets called once per frame, again per game object this is attached to. So those are how the things kind of exaggerate when you have the same script used across multiple game objects. Fixed update is like update, other than the fact that it's controlled how often it gets called. So it gets called trying to maintain 60 frames a second. So that might mean it gets called more often on a computer that's not holding 60 frames a second. It might get called less often on a machine that is getting more than 60 frames a second. When would you set a box collider to be a trigger? When you don't want normal physics to be involved. So if you need to know when something collided with something else, but you don't want it to, the physics engine to act like, to make the thing bounce around and do whatever, you want to handle all the logic associated with the collision, then you can use a trigger for a box collider. Purpose of ragdoll, it's like a placeholder. So we used it specifically for like the death of the zombie baby, where when it died, we made the main character disappear, but we had the ragdoll kind of fly up in the air and look like it died and stuff like that. So it's a placeholder for the for something. Difference between OnTriggerEnter and OnCollisionEnter. So OnTriggerEnter only gets called when we have a box collider involved with the isTrigger setting turned on for it. Otherwise, when we have things that have colliders along with rigid bodies, we have an OnCollisionEnter function that gets called every single time any two of these guys, you know, this will call back to the script associated with the guys who are involved in a collision, and then we can ask whether or not this is a collision we care about based on who collided. All right, so that's, but OnCollisionEnter physics will occur. So, you know, that's using the normal physics engine, it's just letting us know about it. So given that, when would we use each? Well, I mean, the starting point might be if you need physics to happen, but you still want to be able to react to the collision programmatically, then you would use OnCollisionEnter. OnTriggerEnter might work, you know, when you don't want physics involved. Now, even bigger than that, though, we can maybe say that OnCollisionEnter allows us to kind of passively deal with collisions that are happening across the our game. So maybe it's less targeted and more of a, hey, I want to know whenever, I don't know, maybe it's whenever the player touches the ground, the screen flashes or something like that. You know, something that's more of a passive response to stuff throughout the game. Let's see. Necessary line to make game objects disappear upon pressing the H key. So I gave you the code block, and I even gave you the question for the H key. So what you were to come up with is the sprite renderer line dealy flippy. So this .get component, the component we're getting is the sprite renderer. And then we want to turn enabled to false. So we're asking whoever the owner of this script is, the game object that owns the script, to get its component, that is the sprite renderer, and to make it disabled. Turn its enabled to false, which will make it no longer be rendered. It's still there, no longer be rendered though. Okay, what does the following code do? So this is an example of an OnCollisionEnter. So this would be the thing where physics is still involved. If the thing we collided with, so this is within this dot, if the thing we collided with, that is the game object's tag, is equal to a spike. So whoever owns this script, if they collide with something tagged as spike, then we're going to destroy the game object associated with the owner of the script. So that's what happens there when we hit a spike, go away. 7, what is the purpose of an animation controller? All right, so this is the, officially it's something called a state machine. So this is the state machine that's used to hold all the animation types for a particular, well, it doesn't have to be one game object, but for game objects that share a series of animations, as well as the transitions between them, how you move between them. So it's the logic of how we can, the logic of how we move from animation to animation related to an owning game object. How do we use triggers as it relates to animations? Okay, so within the animation controller, we can create variables, and we can create variables of different types. It doesn't have to be a trigger, but we've worked with triggers in here because we've kind of just done static change animation from this to this, that type of thing. We haven't manipulated speed and things, but effectively a trigger is like a quick Boolean, if you will, where when we fire the trigger, we're able to detect a transition between two animation states and say, if we're supposed to be walking, for example, transition to the walking animation. So we use triggers to give ourselves programmatic access to our animation controller through these just setting a trigger. Which in some ways, I think one person said this is an example of MVC. It's a loose example because we don't really have data involved, but a model view controller says that you want to have your interface and your logic separated from each other. So our controller is kind of our interface. That's where we've visually designed how animations move within an object, and then the logic would be when we're writing in our scripts and we grab the animation controller and set some trigger in it. What happens when we add a force to a rigid body? So actually several different things. So adding a force is equivalent to like a push. All right, so we're adding a force to something. Now, there's all sorts of things that play into slowing down that force. Right, we have drag and even gravity. So things play into that force being slowed down, but at least initially there's a force. So if we think about it in space, this is kind of the whole thing with some of the new, they're trying to figure out how to get rockets to go to Mars and not run out of fuel. So you start off with a little push, and then it just keeps building up because you're in the vacuum of space. There's no drag, so there's nothing slowing you down. So if we could treat that as a rigid body, that would be a rigid body in a vacuum that doesn't have any slowdown. Now, keep in mind that Unity is a simulator of real gravity, so you're going to get some strange effects, like we've seen our baby jump funny, so we might have to fake in some numbers to get the behavior to be what we want it to be, even though we know it might not act exactly like that in real life. But adding force to a rigid body effectively is a push and then let physics do what it's going to do. Also, it's directional. So when we add force, we add it in for a 2D game, we add it in a vector 2 direction. We could give it a vector 3, and just for ours, it's 0 on the Z. So that direction could be up, it can be at an angle, it could be right, left, whatever. But we add a force in a direction with a power. So when a lot of times if you remember when we've created this, we might make it go for like our jumps. We make it go a directional force up, but with a power. We'll multiply it by jump power. And that gives us how hard of a shove in that direction we're going to give it. Let's see where we're at. 10, what does the invoke function do and when do we use it? So invoke, we specifically in our game used it on the for respawn after our, we might have used it someplace else, I don't remember. We definitely used it for respawn. So invoke lets us call another function after a period of time. So I think we had it like at 3 seconds. So after the death thing, we threw the ragdoll up in the air, the baby had disappeared, we had a function that got called like in 3 seconds that respawned the baby and dropped it from its original drop point into the scene. So invoke allows us to call a function at a later, after a delay. There's also an invoke repeating, which I don't think we've used yet, but we will use it in the second half of the semester here, which works similarly in that, but it says, wait for 3 seconds, for example, until you call it, and then call it over and over again on some delay. So that allows you to kind of have a behavior that repeats itself, but then you need to come up with a way of stopping that behavior if it's not a permanent type of thing. We've also in here, we have not done send message, right? We've done send message. Okay. So send message would be kind of related to that. So invoke allows us to call a local function. Send message would allow us to call a remote function. But send message doesn't allow us to do a delay. So if we needed to have a delay, we could have an invoke to a local function that then sends a message to another function if we needed to pull that off. But send message allows us to communicate between game objects. And invoke allows us to make calls within the current game object. All right, questions about any of about anything on the exam? Like I said, most people did pretty well. The invoke thing was probably the one missed most often. Ragdoll was another one. I don't know why, but it was. Triggers on the animation controller was another one. Those were probably the 3 that were most missed. Okay, so let's talk about some new stuff then. I promised after the midterm we were going to kind of move on to a different game genre. So what have we looked at in the first 8 weeks? We've kind of gotten used to Unity as a tool. We've looked at it in conjunction with like a game we're all familiar with at some level, Mario. And we've kind of looked at a bunch of different game mechanics, things that we can, that we can relate to. Like how does Mario jump? How do we land on things? And so now if you think about Mario as a whole, with enough time, we can probably start, all those different game mechanics that live in Mario or things that we probably can accomplish at this point, and then it's just a matter of kind of massaging it till it looks correct, where the baby doesn't jump too high or we don't get stuck on edges and that kind of stuff. So it becomes a little bit of a little bit of a trial and error type thing to really get it polished. But in general, we have a fairly good understanding of how a game like that might be put together. Right. All right. So now, historically, how many of you played 2 games I'm gonna throw out there, either Legend of Zelda or Final Fantasy, the original? How many of you played Legend of Zelda at some point? Did you have the real thing, or did you have a Nintendo?
Yeah.
Okay.
All the systems.
Okay. Because Nintendo came out before you. Did you have the Zelda was a gold cartridge for the Nintendo. It's the only one that was different colors. That was really cool. And that was before it was popular. Nobody knew about Zelda before that. But so you had Legend of Zelda, and then you had Final Fantasy. How many of you played the original Final Fantasy on Nintendo? You didn't play the original Final Fantasy? Oh my gosh. Killing me. So let's look at Legend of Zelda, and we're only talking about the original one of these. And let's see. Here's the full walkthrough of the entire game. So we'll watch this for like a minute so you can get an idea what the game looks like. What did I accidentally click on? I think I actually did click the right thing. Oh, hold on a second. Need to plug some audio in. That one. Speaker out. Now remind me when we're done playing audio that I need to turn this off because there's this really annoying like buzz that it makes that will, after about 7 minutes, you go insane. But while the audio is playing, it's not a problem. It's not supposed to be making audio sounds. Right now, it's not making any audio sounds. Let's make sure sound comes out of this guy. Well, for right now, we'll just say this is good enough. So, you got this game, you go from screen to screen, so you have this mechanic where screens kind of slide as you go between places. And this is our hero, Link. Zelda's actually the princess you're trying to save. All right, so there's basically this giant map that we only see a little portion of at any point in time. And so within here, I'm going to forward a little bit through here just to kind of get you. So, we have little entrances. They just showed one there, So this would be like a door you go into, and that takes you into like a lot of times they're dungeons or something like that. So you have this giant map that you're a part of, but you don't necessarily, you don't conceptualize the map. While, you can't see the whole map. You can only see kind of the screen you're on and see that there's 2 or 3 exits or whatever it is. And when you take one of those choices, it slides into the next screen. Now, a lot of the game takes place here. Like, so here we're in a. So this is the first dungeon. You cross this little bridge thing here. And you go into that. So now you're in this dungeon area. So this is a pretty similar type setup where some doors are locked. You got to get keys and stuff like that. But you're picking entrances that lead to next rooms, and each room is kind of fills up the screen, and it's effectively a tile map. Right, and we've sort of we've built tiled things like our platform in the first in our platform. Well, the platforms in our platformer were little tile map things. So, just a bunch of tiles in a row so that we could use the same little block a bunch of times in a row without having to drop a whole bunch of individual little blocks or stretching it out where it got all distorted and things like that. So our screens and a lot of our 8-bit games were really made up of a whole bunch of blocks. Certainly in 2D games, but in you still had kind of that 2D thing even when you went to like the 16-bit games. When you went to Super Nintendo, for example, that was still mostly 2D type stuff, and not until the kind of late Super Nintendo games and then into N64. Did you have no? N64 was the next one, right? Not GameCube. I think it was Super Nintendo, N64, then GameCube. So N64 was kind of the first Nintendo-based game system that had 3D stuff. I think that was that had Super Mario World in it, where the Z-axis was a thing. you went into the world. But in any case, so our games are largely made up of tiles when we kind of think about a big map like this. Now, we've created our little tiles for our platforms, not the end of the world, right? We kind of had to figure out how Unity did its thing for making sure the tiles were the right size and stuff. I think Emma helped us out to get that right. But, in any case, that was doable for like a couple of platforms or something like that. But certainly if you had to design something like this, when we think about a game like Mario, most of it's empty space, right? Most of Mario is air. You just have these platforms you jump on, and that's your real structure. Well, something like this, your guy is moving on the map. So the entire map is tiles. So if you think about this as a giant puzzle, if you had to build each of these, I mean, so we could build something like this line here pretty easily, right? That's kind of like one of our platforms in Mario. This guy here maybe becomes a little sketchier because you have, kind of a pattern. So you might have to build it in a couple little pieces. But certainly, even just building this one room would be fairly tedious, right? That wouldn't be fun. It loses the whole funness of the game design thing pretty quickly when you're like, this is a boring room that is, I'm only going to be in. I mean, you see how quickly this guy lived in that room. He immediately left that room. Okay, so you spend an hour painting this room that he's in for like 2 seconds because nothing happens in that room. You're only ever going to come back to the room once you have the key. Then that's when you have the good stuff. But in any case, and even this next room. Yeah, so there's some enemies in here. This room would be easier to do, but you look at it, you have this effect, right? Where there's like a depth effect. So this thing is kind of sunken in or something like that. So that's more of an artistic type thing, but it's still a 2D thing. But certainly we can appreciate that if we had to build, we would call this a fairly simple scene. If we had to build this using tiles, that might become tedious. We wouldn't really want to do that. All right, so similarly, we'll do Final Fantasy NES. It's just going to show us from the very beginning. It looks like it. Turn these off. So pretty similar type of kind of concept. Big map. Instead of things moving one screen at a time, like Zelda did, it kind of moves along the lines with us. The camera is following us, exposing more of the map on the outskirts. We have some interaction with people, kind of on the normal map, where that only exists in Zelda when you go into caves or something like that. You don't walk up to somebody in the normal map when you might be fighting. And talk to somebody, but in general, we would say that these are pretty similar type of things. This is a tile map type of game where you would build this thing, and again, it would be fairly tedious. We can lay down these little trees and that kind of stuff. We have various type of so here's like a fight in Final Fantasy. So this would, as you're wandering around in Final Fantasy, this is how you power level in Final Fantasy.
However, Final Fantasy franchise creator Hiro world map players would use to travel to different locations and then encounter various enemies. While traveling through the overworld map, players could randomly encounter enemies thrown into
in that particular thing, you're just wandering around and you have no idea that you're about to start a fight. So the fight just starts, and it kind of takes you to this other scene. I'm fighting stuff scene. All right. So that's actually how if you wanted to beat Final Fantasy even more quickly, you would power level. You just wander around in the first thing and get yourself like the level 3 or 4 before you did the level 1 stuff. And then you just beat all the bosses really easy. Yeah. None of you seem that excited about that. So in any case, the entire game is made up of effectively the tile map traversal thing, and then fight scenes like this, where as you were doing the fight, this is turn-based. So it's not like you're button mashing and stuff like that. So this would be a type of game that would be kind of called a role-playing game, RPG. So with Zelda, So this is an RPG game, and specifically it's turn-based. So when we actually, where Zelda, it was real time. So Zelda, you're throwing your the sword things. Now you only get to actually throw the swords in Zelda when you're at full, you have all your hearts. If you don't have all your hearts, you have to run up and smack the guy. You got to get too close to him. It's not, that's dangerous. So, you know, the fight scene, these guys are attacking you first. Looks like now you get to choose what you want to do. Fight magic, drink a potion, run away, that kind of stuff.
Hironobu Sakaguchi was given the go.
So, in any case,
go ahead to make a new RPG.
That's kind of the formula for Final Fantasy. We call those pretty similar games, right, in terms of how they might be put together. Now, for us to start off with here, we are interested in the and I put up a couple of videos this morning that we're going to kind of work through. They introduced a tool called Tile that was hoping that I mentioned last week, that was hoping there was a Unity is coming. Their next version of Unity is introducing some new 2D tools, and one of them is going to be its own tile map drawer type thing, similar to what we're going to look at here. So you can kind of look forward to something like this ultimately getting built into Unity. But right now we're going to use two tools separately. So one of them is called Tiled, and there's some other competitors with this. So I mean, I don't necessarily know if Tiled is the best. And then a tool that translates Tiled into Unity game objects, so that you can bring it into your game as a prefab and have your map there. So we're going to look at this one first, and we're going to pause.
Hey everybody, this is Games Plus James.
Several times in here. Is the audio loud enough in here? Do you want me to get it through the speakers? Can you hear it enough, or is it sketch? It's good? Okay.
Unity RPG tutorial series. Now, in the last episode, we sorted out a way for a camera to follow our player around as he's moving. You can see it's following along behind the player here. But we've only got this one little environment that we're using for the player to walk around in, which is kind of boring, and it's walking off to the side and stuff like that. It's not very interesting. So we need to make some more maps for our game. But at the moment, the current way it's built
while
in Unity, I have heard that they're working on new ways of having like a built.
I want to go back here. So down on the screen, he has the links to the stuff, and we are always at the mercy of what comments people put in there. Where's the oh, there it is. So in his very first comment, here's the actual tile program. It's this mapeditor.org. So I'm going to open that in a new tab because we want to go ahead and get to that guy. All right. So this is the actual tool we'll use for building our maps. And you can choose which of these ones you want to get. I don't want to pay anything. I already paid for this. No, there's a way to get it without paying anything.
Just hit the link where it says no links. Get me the downloads.
What, down here?
No, right above the dollar sign. So right above at the top where it says wait.
Oh, no thanks. Just take me to the downloads. Okay, thank you. So these guys, the ones that we're going to care about is maybe the Windows 32-bit installer. You could do the Windows 64-bit installer. It probably doesn't necessarily matter which of the Windows ones you get for us. I'll go ahead and grab the 32-bit one, even though most of you are probably running a 64-bit version of Windows now. This will still run. So just go through the setup process, install it somewhere where you can find it. So this guy will allow us to build a tile map by kind of painting, and we'll see that through this tutorial. We're going to use the same things that they use in the tutorial, so we'll grab those here in a few minutes. All right, so we'll just leave this guy open for a second, but then we need a way of getting that into Unity, and that's where this second program comes from. So this is called Tiled to Unity. So somebody's written a script to do this. So this one doesn't look all that pretty, but it's you know, gets the job done. So we'll go ahead and download this guy. So Tiled to Unity, Windows installer. We'll download that. That one's only in 64-bit, but that's okay. All right, so we have that guy installed. Now, these are some scripts that they use. We're not going to look at that now. We care most about these ground sprites that he's going to use here in the map builder for right now. So I'm actually we're good. So I'm going to go to these ground sprites. So it's a tile map, and we've seen these before, right? We've seen something like this, and we use the thing in Unity to cut it up. But I'm going to go ahead and download this because we're going to bring this into our into Tiled for creating our scene. So we'll go ahead and download this guy. This one's called Rogue-like RPG. There we go. And that's this guy here. I'm going to go ahead and just extract everything into that folder. That way in our downloads folder, we'll have our Rogue pack thing that has the sprite map on it. All right, so actually they give you some sample stuff that's actually in a map format that Tiled understands, but we care about the sprite sheet itself. So there's here's a transparent version. Why would you want a magenta version? Is this like Underworld or something? Yeah, who knows? Actually, I suppose that's not going to really be a problem because they're cut out. So once you slice it up, you wouldn't actually see it. Maybe that's just a better way of viewing them. I don't know if it's a better way, but in any case, you know, we're familiar with something that looks like this. These are all 16 by 16 little squares. And in fact, you see that all of these are 16 by 16 squares. We ran into some non-uniform ones when we were first looking at this. So these are effectively a box of Legos, right, that we can use for painting. Okay, so now we have the various components we're going to need to follow through this thing. So we'll go back and we'll let him talk a little bit more, and then we'll pause and kind of do what he's doing to get an idea of how this tool works.
In tile editing system, which is what we're going to be using now. But the current way that's built into Unity is literally just to drag, switch back to the scene view here, to drag a block in, place it there, drag something else in, place it there, and line it all up by hand and by eye.
Yes, that's the Unity way of doing it.
That's not very helpful at all. So what we're going to use are two programs that are free to download. There'll be links in the description down below. The programs are called Tiled and Tiled to Unity. And Tiled is basically the program that you use to draw your maps in, and Tiled to Unity is a program that converts those files into Unity for you. It's all relatively straightforward. So first we're going to take a look at Tiled. So I have it open here. So once it opens up, you'll have something that looks roughly like this. And we'll put this over to the side. And what we obviously want to do is create a new map. We want it to be orthogonal, and that just means basically it'll be squares, rather than isometric being the kind of like almost diamond view or stuff like that. But we want to stick with orthogonal. Tile layer format, that's fine. Render order, I prefer to have it left down so that it goes from the top corner, but you can have it's basically like a starting point for where you move your objects around. So left down, we'll put the thing in the start point in the top corner. Left up, we'll put it in the bottom corner up and stuff. So
this is where your access starts from.
Doesn't really matter too much. We'll go with 75 by 75 for the height.
So the left down will say that 0, 0 is up here for your XY axis.
Height and width. And their tile size width.
So now he's building, so 75 tiles wide, 75 tiles high, where each of these tiles is 16 pixels. So what's 16 times 75?
Yes, would be.
Yeah, so that's 1200 by 1200 resolution. So, one issue you could run into, depending on how much, because there's a zoom factor here. So depending on how much you showed at a time, we have monitors today. This monitor could do it. They could show that entire map at once in terms of the actual number of pixels that are on that map. They would be tiny, right? But you could show the entire map at one time. Now, we can imagine, so when we think about how this thing is actually put together, you look at those games like Final Fantasy or Zelda, those maps are going to be way larger than 75 by 75. They're, hundreds by hundreds. Okay? That's why they had to have a game mechanic to decide what to show you when. Some of those games do have a way to kind of zoom out and look at the map as a whole, so you can see it from like a sky view. But usually that's actually a different map. It's not. You're not looking at a zoomed out version of your real tile map. You're looking at kind of a Game of Thrones-y type of intro thing where they're showing you kind of what the world of this thing looks like geographically. So how towns are connected to each other, where the castle is, that kind of stuff. So you have a general idea that I need to go northwest to get to where the boss probably is, something like that. But generally, we would have on a per level basis, we'd have a relatively large map that we would lay out, and a majority of it is made up of the same kind of crap. You think about Zelda, you got kind of trees that give you borders, and you can't run through the trees. There were specific areas where you were allowed to cross into the next scene, right? So the Zelda world is kind of made up of a bunch of boxes, right, that are tile map sections, whereas Final Fantasy was a little bit more open world, if you will, until you got inside of buildings or something like that.
Right. It needs to be 16 because, as we know from the tiles when we first used them.
So this 16 by 16 thing, that's going to be driven by your tile set. And the tiles we're using are the same ones he's using, and they're 16 by 16 in terms of size.
They're 16 pixels by 16 pixels wide, so we want to stick to that. So we're going to hit OK here, and we end up with a big black map. And then we need to import the tile set that we've used for our images. So if we go here and click on New under the tile sets area here, so it's going to be, we'll just call this base tile set, and we're going to load up from our download from our resource pack that we've been using in the series already so far, which is still linked below this video, of course. We're going to open up the sheet of all the objects that we want to use again. We're going to open that up, and we have our tile width and tile height set at 16, but we want to set the spacing. I already have this set We want to on yours it might be set to 0 by default. We want to set the spacing to 1 because, as we know, on that sheet there's a one little gap between each tile to make it all spread out and make it all easy to manage. So we hit OK there, and then we get this.
So let's go ahead and get ours where he's at. So we'll open up this guy. Let's go ahead and create a new map. We'll do orthogonal. We'll leave the layer format the way it is. We'll go with what he did. So he did left down, right? He had his 75 by 75. It's probably not a big deal, but we'll match him just for the sake of following along. And our width of our tiles are 16 by 16 in our case. All right, we'll go ahead and save this. I'll throw it on, I guess I'll throw it on the desktop. And we'll call this guy game map. We'll hit save. All right, so this thing looks like this initially. We'll go over here to our tile sets. Add something new. I think he called it like base tile set or something like that. We'll choose our file. So our file was in downloads, and then it was in this roguelike pack. Then it was in sprite sheet, and it was this one with a transparent background dealy. All right, and tile width is 16 by 16, and then he made the spacing a 1, just because when you look at that tile map, you see that all the squares aren't put together. There's a little space in between each of your tiles. So you're describing here what your tile set looks like in the image, so that this guy can slice it up, just like we had Unity do earlier in the semester. Okay, so we'll go ahead and save that. We'll call this guy base tile set. We'll also put that on the desktop. All right, so that gives us this thing. There we go. This is the view I wanted to have. Let's see if I can. Well, we'll mess with zooming as we get farther in here because I want to make sure these things are big enough for us to see. Just let me go higher. Yeah, let's do. Let's go 200% there. Then we'll kind of show maybe that much of it. We'll start with that and see what that ends up feeling like. Okay. Oh, we had it. It opened up and
yeah, all the tiles broken out like this, and then to draw with anything, we just literally just click on one that we want and go over here and just click and drag, and we can draw any kind of shape that we want.
Yeah, so he just grabs some grass from over here, and then you can draw in your whole grass. And there's a paint bucket thing, so maybe you want the entire 75 by 75 thing to be grass. So there's grass. A lot easier than dropping all that stuff in Unity.
Like that. We're getting all these little kind of blue boxes are just kind of a little bit of artifacting that actually won't show up in your game. So you scroll down, see, there we go, it's disappeared. But it's quite handy, so we can just draw like that, or if we were to use this tool, we can just select one big area like that, and then select our paint bucket and go boop and fill them in, and switch back to our normal tool. And we can, I think we can deselect this by Control and D. No, Control Shift and A. There we go. That's what I meant to do. Okay, so we've got.
Question is that my computer
kind of
getting all those things?
here.
I think it's
might as well
his.
just fill in the whole map with green
He's
ground,
a slack.
like that.
So, it's a slack.
There's actually two little green grounds here which are ever so slightly different. It's hard to really tell the difference, but they are very slightly different. And to add a little kind of variety into the world, if we click and drag on the both of them to select them both, and then go up to this little dice roll here, what that'll do is it'll randomly place stuff. So we have the paint bucket still selected. If we go back over this and we hit that, now what happened is, you can see as we're moving now, we're no longer able to paint the whole area at once because it's randomly painted one or the other all throughout it. And probably a better example of that would be if we select a green and a brown one here, and we leave it on random, and we have it on our paint bucket, and hit that. See, we get these, it randomly places stuff all over the place. So it's just an easy way to add a tiny bit of variety into your game. But you probably wouldn't want to just have green, brown things all over the place. But so next thing we're going to do is add a little bit of water. I'm going to just do it like this. And then around the edges of the water, we need to just draw all the...
So let's go ahead and catch up to that. So he's going up to here, one of the water tile things. So he starts off with, let's deselect the paint bucket. So we'll just draw a pool. And if you noticed before, I think he did something like this. We can use the selection tool in the fill bucket. And then go ahead and fill it in so you can kind of draw your pool first and then get it in there. Now notice here it's showing us our full map over here, so you can kind of visualize where things are laid out relative to other things. Then he went ahead and on the outside here, he drew in the, oh, I need to do this guy. So he drew in the, why isn't it drawing? I don't know why it wasn't letting me draw before. Oh, maybe I had to get out of the fill mode. Letting me draw now. We appear to be in like some sort of selection mode. Let me save this real quick. Why isn't it letting me draw? acts like it wants to let me draw.
It's not deselected first.
The grass?
No, it's not deselected. We'll stop on the left of the pool.
Oh, I see what you're saying. That's still highlighted over there. Oh, so it let me paint that in there. So that would be what you're saying. So how do we deselect our original selection?
I think the selection tool again.
This guy?
Yeah.
Maybe we can select a new area. Like I wanted to just, oh wait, oh. Okay, so I'm guessing I can paint now. Go ahead and put my corners in. Well, it's not the same, but it's close enough. My gosh. You can like really easily go too far. All right. Good enough swimming pool, I think. Call that good. All right, so we've drawn our pool looking thing here. Now, we would think normally, so, you know, kind of thinking ahead here where this is probably going, you know, if you're walking along campus, so we kind of just drew in, well, maybe this is the pond by the field house, right? When you get close to the pond, what do? You stop walking. You go around the pond. Okay. So, you know, in any case, now officially in real life, the pond, you can just walk into the pond if you want, right? But none of us would probably do that unless it was like a joke or something like that. So officially, the pond is not stopping us from walking into it. But in practicality, it is, right? The pond is effectively marking itself as not walkable. Right, so we want to have a way of adding some collision to this so that as our dude is moving through the world, we bump up against this water as if it's a problem, right? It's a hindrance for us.
Little bits here like this. Now, we're going to take a look in a second. You can set up special ways so that you can just like draw one big block and it'll automatically fit in so you don't have to go around the edges. But I'm just showing the different ways of managing the maps in this. So there we have a nice little bit of water in our world for our player to kind of stand out and see. If we hold Control and scroll up and down, we'll be able to zoom in a little bit and see how it looks. We'll zoom back out here. But we don't want our player to be able to walk into this water from off the land, because that would look kind of weird. We want this to represent a deep bit of water, so the player won't be able to walk into it. So we need to give this bit of water some collision. And way we do that is if we go up here and click on View and then Tile Collision Editor, like this, it opens up a little box here that we can basically draw within an area where we want a collision box to be made, and then the player won't be able to walk into that area, basically. So if we just hold Control and zoom in on this again, we're going to click this box here, and then click in the top left corner and just drag it down to the bottom right like that. And then this creates a box over this whole area that the player won't be able to walk into. There's no quick way to do this really, or not that I've encountered. And then click in the top where we want a collision box to do that is if we go up here and click on View and then Tile Collision Editor, like this. It opens up a little box here that we can basically draw within an area where we want a collision box to be made, and then the player won't be able to walk into that area.
Now, what we're effectively doing here is we're setting these tiles up as having colliders on them. So once we do this once for a tile, that tile is now, we can paint with that, and it paints with a collider from that point forward. So, and it also will update the other ones. So we don't have to go and do this for every single water thing we ever have. At the same time, though, we also run into a situation where what if you want to have water that isn't a collision? You might have to either create a second tile set that has the non-collidable dudes in it or something along those lines. So this convenience does come with a possible downside.
Basically. So if you just hold Control and zoom in on this again, we're going to click this box here and then click in the top left corner and just drag it down to the bottom right like that. And then this creates a box over this whole area that the player won't be able to walk into. There's no quick way to do this really, or not that I've encountered. Maybe there is and I just haven't found it yet.
So let's go ahead and do that. So we'll go ahead and click on one of our, we'll just go in the grid here. So we'll go to View. Don't see it in there. Possibly object type editor. Unless we get to it. There's something down here. No. That doesn't seem like it's going to get us there. Don't see any of the menus up there. What about down here? Anybody else find it in their drop downs? All right, so we're looking for collisions.
So we moved where it was. So if you underneath the tile set, so you need to edit tile set.
So here,
And down there at the bottom.
edit, export, edit. Okay.
And then you can select the tile you want, and up at the top, the two little like outline boxes next to each other is the tile.
Two little outline boxes. Oh, these guys?
Get down.
So I wonder, then can you select more than one of these? Well, selecting more than one of them might not actually help us. I was going to do like to select the whole thing as a... Okay, and let's zoom into this guy. Well, they don't make it you would think that it would not just keep painting them over it over and over again. Okay. Is there a way to get rid of some of those? Or is all is lost at this point? Remove object. Okay. So let's say we've done that. I'm going to do it for each. We're going to call our accuracies here suspect at best. My guess is if they move this, they probably have a better way of doing these all at once, or at least doing it less with higher precision, but less trying to draw the perfect square. So we are probably not doing it in the most efficient way. Okay, so we're going to call that perfect. We'll go ahead and save that. Go back to our game map. And which tool do I need to select here? just unselect. So it should show these guys highlighted. If I go back in here, we'll see after he plays this little game with all these guys.
As far as I know, the only way to do this is for every object you want, we're just going to click and drag all of these. So we also want to look at, like I was just saying, ways of making it a bit easier to draw these kind of big chunks like this. And that's using a thing called a terrain, which is if we click on terrains here to the side.
Back here for a second.
And now, although you can't see it here, we've given all these water bits collision. They will have collision in this map when it's put into the game. So we also want to look at, like I was just saying, ways of making it.
Just to show that it worked. I just want to see that what we did definitely worked. I'll select that guy like we're going to paint it in here. And I'm not getting that same feedback as he had. And it looks like they all have the box we drew around it. I'd like to see that working before we move to terrains. Because terrains is kind of cool. What it allows us to do is it allows us to kind of draw big areas. Like, for instance, the water. We could just draw a big pool, and it will go ahead and put the curves and stuff in for us. And so that we don't have to be that precise. And it, we just have to teach it how it should look. So I suppose the collision thing is at the end of the world right now. It looks like it's in there. I mean, when I select these guys after the fact, it looks like they're all selected. So what we're going to do is, and this, I'm not going to make this due on Thursday. It'll be due next Tuesday, but if you want to start working on it, you can, because I want to introduce some more of the stuff here. We're going to build a map kind of in the style of, probably something more like Final Fantasy. Is I think what will make more sense given what these tiles look like. So you take the same tile set that they have from the video, and I've linked the videos there, and we're going to draw a big map. The 75 by 75 is fine. I mean, we don't have to draw a gigantic world. Put some, you can probably build some little house areas and put some tree areas, stuff like that in there. And then we're going to have some water. But ultimately, we're going to take that as our tile set. We're going to expand on that map, on what our capabilities are on Thursday. So, and I've put both videos on there. So if you want to watch ahead and get a head start on it, you can. But you're going to have a map due on a week from today. So if you want to start working on it, you can. But right now we've only introduced a couple of things in class. Make sense? So questions about tiled at this point. We haven't actually done the conversion thing that goes back into Unity, but all it does is takes whatever we build here and turns it into a prefab that we can just drag into our scene in Unity. Okay, I will see everybody on Thursday.